Now we are going to learn about circles. So you should already might know by now that what circles are. This is a circle. So you should already know by now that the area of circle is dependent on its radius. The bigger the radius of the circle, the larger the area of the circle. So radius is the point. Radius is the length from the center of a circle to the circumference. So from center to circumference, the length is always same for a circle, and that is called the radius. So for a circle, its area is pi r square. The area is pi r square, and the circumference of a circle is 2 pi r. And what is meant by the circumference is the length of the outline of the circle, or the length of the border of the circle, this length. So that's also dependent on the radius of the circle, which is r, which we always denote by r. This is the center and the radius is r. And for circle, the circumference is, or you could also say the perimeter of the circle, outline of the circle, circumference equals to 2 pi r. Now that we know the area and circumference of circle, it would be easier to learn about the sector area and arc length for circle. So here we can see that this part shaded and bounded by angle theta is not the whole circle. It's a part of the circle. It's a theta part of the circle. So just like fraction, in fraction, when we write let's say 1 by 4, that means we are interested in let's say we are dividing this thing in 4 parts. So when we write 1 by 4, we are only interested in one part from these 4 parts. So as this part of the circle is bounded by angle theta, and if we want to find the sector area, area of sector, this is a sector for this length, for this angle theta. If we find this, if we want to find this area, we are only interested in theta part from this whole 360. A complete angle, you should know that a complete angle is 360 degree, 360 degree, and this angle is theta. So here we are interested in theta from the whole 360 degree angle. So we write just like if we compare with this fraction thingy, theta divided by 360 into pi r square, as the area of this whole circle is pi r square, and if we write theta divided by 360 into pi r square, we will get this area. Now about arc length. Arc length is related to circumference of circle. When we write, let's first know what an arc is. So this part of the circle subtended by the angle theta, when we say arc length of this circle, the arc length would be this part. This is the arc length. a part of the circumference. That's a part of the circumference. Theta divided, that's why we write theta divided by 360 into 2 pi r. That's the formula for arc length. Only this length. Now we are going to learn what a chord is. A chord is any line that divides the circle into two parts. That cuts the not divide, that cuts the circle into two parts. So this chord is cutting the circle into this part and this part. Let us say this is a whole circle, and the chord is cutting the circle into two parts, and the part consisting of a smaller area is called the minor segment. Smaller, minor. This a part consisting of a smaller area is called the minor segment, and the other part is the major segment. This part is the major segment. So here sometimes one thing you need to you should know two things that is related to chord, and that's when you draw a line from this center, from the center of this circle here to the midpoint of the chord. I am denoting the midpoint of the chord as M. That means midpoint, I mean this point is dividing the chord into two equal parts, two equal lengths. So if I draw a line from the center to the midpoint of the chord, it's definitely bisecting the chord. Bisecting means dividing into two equal parts. It's definitely bisecting the chord at right angle. That means this angle is 90 degree. If we draw a line from the center to the midpoint of the chord, this line is bisecting the chord at 90 degree, and this angle is 90 degree. Another thing, along with bisecting the chord, it's also bisecting the angle here. It's also bisecting the angle here, and these lines O and OB, here angle theta is the AOB angle. It's also bisecting this angle when we draw the line OM from the center of the circle to the midpoint of the chord. That means the angle becomes this part of the angle is theta by 2, and this part of the angle is theta by 2. So the two things is that the line from the center of the circle to the midpoint of the chord is bisecting the chord at a right angle, and this line is also bisecting the angle subtended at the center of the circle. Okay, that's all about chord. It would be more easier to understand if we solve some problems related to this. We are going to find the shaded area for this shape. This is a circle of radius 6 centimeter, and inside the circle there is a regular hexagon. By regular hexagon, by regular hexagon I mean the 6 sides of the hexagon are of equal length, these 6 sides. So that means this angle, this angle, this angle, this angle, this angle, this angle would be equal. The we know that the complete angle is 360 degree. Complete angle is 360 degree. So this angle would be as this angle is 1/6 of this whole angle, 1 2 3 4 5 6, as this angle is 1/6 of the whole angle. This angle is, let's say, theta. Theta equals to 1/6 into 360 degree. That means it's 36 degree. Sorry, 1/6 into 360, that makes 60 degree. 60 degree. So I said that the radius of the circle is 6 centimeter. It's mentioned here. So this side is 6 centimeter. 6 centimeter. And in triangle, if we know the two sides and the angle between them, we can find the area of triangle. So the area of this triangle, if I mark it blue, the area of this triangle would be half area of triangle equals to half into 6 into 6 into sine 60, half AB sine C, if you remember it, half into 6 into 6 into sine 60. That's the area of triangle, and that makes 18 sine 60. 18 sine 60. So the reason we find the area of triangle to find the shaded area is because if we remove the triangle, from the this sector, if we remove the triangle from this sector area, we would get this. So the sector area here, okay, so it's not necessary, I think, to find the sector area, because these 6 triangle are same. These 6 triangle are exactly the same, 1 2 3 4 5 6, because the hexagon was a regular hexagon. As this 6 triangle is exactly the same, we can say the area of regular hexagon, equals to 6 into 18 sine 60, because we wrote 6 here because 6 equal triangle are making this regular hexagon. So that makes 6 into 18 sine 60. Okay, so to find the shaded area, we can write shaded area equals to area of circle minus regular hexagon, because we are removing the hexagon from the circle, from the whole circle. So, area of circle we know is pi r square, and the radius of this circle here is 6 centimeters. So, pi into 6 square, that makes 36 pi, 6 square equals to 36, 36 pi minus area of hexagon, that is 6 into 18, 6 into 18 sine 60, 6 into 18 108, 108 sine 60 equals to 36 pi minus 100 sine 60. That gives us, if we remove the hexagon from this circle, this gives us area 19.6 centimeter square, and that is the shaded part of included here. That is all for today. Thank you.